Okay, so here's another problem regarding graphs of cubic functions or cubic equations. Okay, so the diagram below shows the graph of, this is y is equal to x to the power 3 plus 3x squared minus x minus 3. Okay, y is equal to x to the power 3 plus 3x squared minus x minus 3, and this is how the graph is looking like. Okay, so this is how the graph is looking like, and I've always said that it's very much important that anytime you plot your graph, it's important that you always indicate that equation. The equation more like gives an identity to the graph that you have made, if it's either a linear, quadratic, or even cubic function. So it's very much important that even if you have been asked a question to sketch or even plot a graph, it's very much important that after you make that, you should label that graph with the equation that you were using to plot it. Very important. Very important. So again, feel free to pause the video, and if you want, you can just copy this and then you can follow up with me as we now begin to handle the solutions. So again, they're saying use the graph to find the solutions. Okay, use the graph to find the solutions of the equations x to the power 3 plus 3x squared minus x minus 3 is equal to 0. X to the power 3 plus 3x squared minus x minus 3 is equal to 0. Remember, like we had seen previously, it's very much important that you compare these equations that you have been given to solve with your original given equation. So this is y is equal to x to the power 3 plus 3x squared minus x minus 3. This is our original equation. The one that we have been asked to solve is x to the power 3 plus 3x squared minus x minus 3 is equal to 0. Same thing, I can rewrite this. Okay, I can rewrite this in a suitable way that is going to be more like this one. So if I make these the subjects of the formula instead of y, I'm going to have x to the power 3 plus 3x squared minus x minus 3 is equal to y. Okay, x squared, or x to the power 3 plus 3x squared minus x minus 3 is equal to, firstly, 0, and in the second one, y. Again, look at what we have. You're going to see that y is just being equal to 0, and remember, it is only in the x-axis that you're going to find your y value being equal to 0. So like we had said, you're going to come on your graph. Once you come on your graph, just see where this graph is meeting with your x-axis. Okay, so remember our x-axis is like this. So we're just going to see where this thing is just meeting up with your x-axis. Alright, so this graph is meeting your x-axis at -3, -1, and +1. Those are your solutions. You don't even need to stress, you don't even need to waste your time. You're just going to see where this graph of yours is just meeting with your x-axis, because when you were making an analysis here, we noticed that y was just being equal to 0, and that will only happen anytime you're in the x-axis. Okay, so your solutions will therefore be x will be equal to -3, x will be equal to -1, and x is equal to +1. These are your solutions for this problem. The first one, that is, x is equal to -3, x is equal to -1 and x is equal to +1. Just look at where the graph is meeting up with your x-axis. The second one that we have been given here is x to the power 3 plus 3x squared minus x is equal to 5. X to the power 3 plus 3x squared minus x is equal to 5. So again, compare. So y is equal to x to the power 3 plus 3x squared minus x minus 3. And we have been given x to the power 3 plus 3x squared minus x, and then this is being equal to 5. Now, it's very much important that we play around with our original equation. Let us try to fashion, let us try to model it in a way that is somewhat similar to this one here. Notice that we are having x to the power 3 plus 3x squared minus x here, which means that as you are making this one into this form, you should make sure that you only make x to the power 3 plus 3x squared minus x as the subject of the formula, meaning that this one is going to be looking like x to the power 3 plus 3x squared minus x minus 3. So remember, I'm trying to change this guy. Minus 3 is equal to y. Y is there. We don't have a problem. So this is now going to be, so see, we are only having x to the power 3 plus 3x squared minus x only. Here we are having x to the power 3 plus 3x squared minus x minus 3. So this minus 3 will be considered to be invalid because we're trying to make it look like this guy. So the -3 will be transferred, will be taken to that other side. Hence, what you're going to have will be x to the power 3 plus 3x squared minus x is equal to y. This is -3, so when it comes to this side, it's going to be +3. So this is going to be y plus 3 in that way. So if we compare this guy and this guy, you're going to see that this is x to the power 3 plus 3x squared minus x. This is also x to the power 3 plus 3x squared minus x. But this is being equal to 5. This is being equal to y plus 3. So the same way we were coupling the values, like the way we did it here, y was coupled up with 0, as in we said y will be equal to 0. It's the same thing that we're also going to do here. The y plus 3 is going to be coupled together with the 5 that is here. Hence, what you are going to have will be y plus 3 will be equal to 5. And once you do that, the 3 is going to be taken this side. So this is going to be 5 minus 3, because it's a positive, so when it comes there it's going to be a negative. So it's going to be y is equal to 5 minus 3, which we all know that the value is just going to come out as +2, right? +2. So y is equal to 5 minus 3. 5 minus 3, the value is just going to be equal to +2. So that's the +2 that we have there. Okay? The +2. Y will be equal to 2. Now again, someone can be like, I'm done. But, well, you aren't. This y is equal to 2 should now be plotted. Okay? This y is equal to 2 should now be plotted. So, how are we going to plot this y is equal to 2? That's the question. Well, it's y is equal to 2, so you're going to locate 2, that is where it is on your y-axis. Okay? This is 0, this can be 5, so probably this is going to be 10. So maybe your 2 can be somewhere down here. Okay, just somewhere down there. Okay, that's where your 2 can be. And then if we try to make a sketch, or rather if we try to plot it, okay, if we try to plot it, this is how it's going to be. Let me try to use a red pen on this guy. So it's going to be in that way. It's going to be going like that. There we go. Yeah, like that. That's your y is equal to 2. You just draw a line horizontally and be sure that it is passing at your 2 value. So this is your y is equal to 2. I hope it's not a hard thing. If maybe you were given to say, can you plot x is equal to 4, x is equal to 4, you're going to come in your x-axis. Your x-axis is having a 4 here. So what you should do is that you should just draw a line vertical or perpendicular to the x-axis, passing at 4, because that's what they said, x is equal to 4. So that line should be drawn vertically and it should pass at 4. This is y is equal to 2, so you should draw a line horizontally, okay, horizontally, and you should make sure that it should pass at 2 in your y-axis, okay. So again, you're not done. It's important that we see exactly where this thing is meeting up with your graph. So where are they meeting with your graph? Here. We also have here, this point here. We also have another point there. Okay. So there is another one here, and there is also another one there. So again, we are just approximating, and these are going to be our solutions. You know, it doesn't matter whichever one you start with, as long as you're just giving them the values, it's okay. I'll start with this guy. So notice we're counting in this way. So someone here can be in a rush to be like, hey, maybe this is going to be negative 3.4. Well, what's your file right there? Negative values proceed in this way. So you're still in your negative 2 to negative 3 range. So this can probably be negative 2.6, just by approximation, negative 2.6. Let me write that better, negative 2.6. The other one is going to be x is equal to, and then this is going to be negative 1.2, right? We're going in this way, so it's going to be negative 1.2. It's fine. Negative 1.2. And is that an M? And you know, positive values going that way. So this is 1 point. Again, it can be 1.2, a positive, but positive 1.2, and that's it. You have used your graph to find the solutions of these equations. X to the power 3 plus 3x squared minus 6 minus 3 is equal to 0. And of course, x to the power 3 plus 3x squared minus x is equal to 5. Now, the next question, they're asking us to calculate an estimate of the gradient of the cave at the point negative 3, 0. Okay? The gradient of the cave at the point negative 3, 0. So, just to make things interesting, I'll use both methods here. I'll use the calculus method first, so that we can just get ourselves acquainted with it. The calculus method. So remember, in the previous video, I told you that the calculus method, or calculus generally, is in 2 pathways. There is differentiation and there is also integration. Okay? There is differentiation and integration. So anytime you're using the calculus method, we always use differentiation rather than integration. Okay, we always use differentiation rather than integration. So the equation that we have been given is y is equal to x to the power 3 plus 3x squared minus x minus 3. Okay, so by differentiation, y becomes dy dx. This is an expression for the gradient. I will try to show you that. Let me just get done with this. So there is a 1 here. 3 times 1, that's going to be 3. X 3 minus 1. We always reduce the power by 1. 2 times 3, that's going to be 6. We multiply the power by the coefficient. X 2 minus 1, right? Minus, of course, this is going to be x 1 minus 1. We do not include the 3 because the 3 is not having any x with it. Okay, that's the best way I can just explain this simply. Any number that is not having the x variable with it, don't try to differentiate it. So this is going to be 3x squared plus 6x minus 1. There is a 1 here. 1 minus 1 is 0, so this is going to be x to the power 0. Any number, any letter raised to the power 0, the answer is just going to be 1. So your dy dx is going to be 3x squared plus 6x minus 1. Okay? Now remember, you have been given a point here. They're saying the gradient of the cave at the point -3, 0. There is a point -3, 0. This is your x value, this is your y value. Remember, in the previous video we were using our x value to determine the gradient. So your x here is -3. So in your answering, you can say let x be equal to -3. This is going to be 3. X, you're going to put -3 squared plus 6, -3 minus 1. And this is going to be equal to, I believe this is just going to be 27. 27 here, this is 9 times 3, 27. 6 times -3, that's going to be -18, hence the minus there. Minus 1. Okay, so this is going to be 27 minus 18 minus 1, which I believe the answer is just going to be 8. So your dy dx is just going to be 8. And that's it for this problem. You have determined your gradient. Your dy dx at the point -3, 0 is going to be given by 8. Now, let us try to use the tangent method. Let us try to use the tangent method. May this be an introduction to the calculus applications of differentiation. The tangent is a line that is just going to meet the cave at one point only. A cave or a circle at one point only. The line that you're going to draw perpendicular to the tangent is what we refer to as the normal. So this line here, this is your tangent. This line that we have drawn perpendicular to the normal, or rather to the tangent, is what we refer to as the normal line. So the tangent line, the normal line. Don't forget that the gradient of the tangent multiplied by the gradient of the normal, the value always comes out as -1. Just one more time, if you multiply the gradient of the tangent by the gradient of the normal, the value always comes out as -1. More problems concerning this are going to be handled later on. But for now, just know that the tangent is that line which meets the cave or a circle at one point only. So Here we have been given -3, okay? Here we have been given -3, 0. So it's very much important that you locate where this point is. So your -3, 0 is going to be here because x is -3 and y value is 0, and like we have said, it is only in the y-axis, or rather it's only in the x-axis where your y value is going to be equal to 0. So your -3, 0 point which they're talking about is simply here, just right here. So what we're going to do is that we're going to make sure that we draw a line that is going to meet this point at one point only. So if we draw, it might look more something like this, okay? It should pass through that point at one point only. Meet that point. So it can come out in that way, okay? It can come out in that way, just like that. So that's our tangent point or tangent line, okay? It's meeting this cave at -3, 0. You're not seeing it bend in this way or anything like that. No, it's meeting that cave at only one point, okay? So drawing the tangent is not enough. What we now do is that we now determine the gradient of the tangent, okay? We now determine the gradient of the tangent. Now again, I want you to see something. We said that the tangent is that line which meets the cave at one point only. The normal line is that line which we draw perpendicular to the tangent. They always form a 90 degrees angle with each other. This means that the gradient of the tangent and the gradient of the normal are never equal. But however, the gradient of the tangent and the gradient of the cave at the point where they meet, the values are always the same. Take note, the gradient of the tangent, gradient of tangent is always equal to gradient of cave. And this will only be true at the point where they are meeting only, okay? At the point where the tangent and the cave meet, the gradient of the tangent and the gradient of the cave are equal, okay? The gradient of the tangent and the gradient of the cave are equal, okay? Don't forget that. So once we do this, what we're now going to do is that, having seen that this is a line, we are going to pick any 2 points on this same line, any 2 points on this same line. How is it that once we pick those 2 points, once we pick any 2 coordinates from this same line, we'll be able to determine the gradient, okay? We shall be able to determine the gradient. So watch this. The first point which I can pick is the same -3, 0. That's the first coordinate that I can pick. I can label this as my A. My B this can be -2. I'm certain this can be 8. So the other one that you can pick here is -2, 8. We always start by picking the x value and the y value. So -2, 8. Maybe this one. -2, 8. how are we going to determine our gradient? This is your x, this is your y, this is your x, this is your y, x1, y1, x2, y2. Okay, remember every coordinate always starts with an x value and then the y value. Now let me show you something. M is going to be given by y2 minus y1 over x2 minus x1. This means change in y, and we write that like this. This means change or difference in x, which is going to be written like this. So this is a delta sign in the Greek, which represents difference. Now, having seen that it sort of resembles d, and of course it's delta with a d, they now translated it to just dy dx. That's why I told you that the gradient and dy dx are just basically more like one and the same thing. Dy dx is an expression for the gradient. But again, our y2 is 8 minus our y1 is 0. Okay, our y1 is 0 over our x2 is negative 2 minus our x1 is negative 3. 8 minus 0, 8. Negative times negative, positive, so this is going to be negative 2 plus 3. 8 will be equal to negative 2 plus 3, the answer is going to be 1, positive. And we all know that 8 divided by 1, the answer is just going to be 8. So your dy dx, or your gradient, is just going to be 8. Using the calculus method, our gradient was 8. Using our tangent method, the gradient is still coming out as 8. Okay, so the calculus method, however, is far much more efficient in determining your gradient than the tangent method, because of course when it comes to sketching, plotting graphs, I mean, different people plot things similar but a little bit different. Someone maybe using the tangent method can find an 8 like I've done. Perhaps someone might have found maybe a 7 or a 9. Okay, so the tangent method isn't exactly that much reliable in determining the gradient. The calculus method is much more efficient in doing so. Okay, but if a question has been given to say using the tangent method or by drawing a suitable tangent at the point they mention, I mean, just go in this usual way. Just use your tangent method. Don't try to use the calculus method because an instruction has been given at that particular point. Okay, so that's how you can determine the gradient using the calculus method and also using the tangent method. The values are agreeing. So don't forget, one more time, at the point where the tangent and the curve meet, the gradient of the tangent and the gradient of the curve are the same. However, the gradient of the tangent and the gradient of the normal are not equal. They are not the same. If you multiply their values, the answer always comes out as negative 1. Okay, the value always comes out as negative 1. So I normally like showing people this trick. If the gradient of the tangent is 3, 3 is just the same as 3 over 1. So how you can play around is like this. If the gradient of the tangent is positive, the gradient of the normal becomes negative. Take the 1 up, bring the 3 down. And that's it. That's the gradient of the normal. That's a faster way rather than using this formula of yours. That is, the gradient of the tangent times the gradient of the normal is equal to negative 1. Maybe just another one. maybe you have found it to be negative 2 over 3. That's the gradient of the tangent. Well, the gradient of the normal, if this one is negative, then the gradient of the normal is going to be positive. You take the 3 up, the 2 down, and then you're just going to have 3 over 2. That's how quickly you can determine the gradient of the normal, having known the gradient of the tangent. Okay, but again, more problems regarding this are going to be given further later on, but I hope this is making sense for you. Okay, and then lastly but not the least, we are being asked to determine the area bounded by the cave. X is equal to 0, y is equal to 0, and y is equal to 20. The area bounded by the cave, x is equal to 0, y is equal to 0, and y is equal to 20. 4 things have they mentioned here. Area bounded by the, number 1, the cave. X is equal to 0, y is equal to 0, and y is equal to 20. Can we focus on this? And this guy? X is equal to 0, remember, that's the y-axis. Y is equal to 0, I don't know if you remember, that's the x-axis. You need to interpret these things correctly. And y is equal to 20. So let's do this. X is equal to 0 is your y-axis. This is the one here. Y is equal to 0, that's your x-axis. Okay, that's your x-axis. This is the one that is coming this way. And then they have also mentioned to say y is equal to 20. Okay, y is equal to 20. Y is equal to 20 is this line here. So this one, and also by the cave, this one. This is the area they're talking about. This one here. Remember, y is equal to 20 is this line. You are not going to continue by reaching down this side. That would be wrong, because they had put y is equal to 0 as the boundary or the x-axis. Again, this shape looks very, very familiar, if you ask me. Very, very familiar. If you look at it, it looks more like a trapezium. Okay, it looks more like a trapezium. So having seen that it looks more like a trapezium, I mean, we can apply the trapezium formula, which I had given you in the previous video, to just be I think that was A is equal to half A plus B H. Okay, A is equal to half A plus B H. So remember, let me just try to outline it. It's having this shape. So this is your A, this is your B, not forgetting this is going to be your H. Okay, that's going to be your H. So if we apply the same concept here, this is going to be your A, this is going to be your B, and of course this is going to be your H. This one's going to be very easy, I think. So let us see how we are going to determine our A. Our A is starting from 0 to 1. So it's just like 1 minus 0, or just 1. Your B is starting from 0 and it's going all the way close, maybe 2.6. Let's try to approximate that. 2.6. Our height, remember, it's just 2.6. There won't be any need for subtractions because they're starting from 0. 2.6 minus 0, just 2.6. 1 minus 0, that's just like 1. No need for you to struggle. Your height is starting all the way from 0 to 20. So 20 minus 0, that's just 20, right? 20. And that is it. Okay? H is equal to 20. So, what are we therefore going to do? This is going to be a half. Your a is 1. Your b is 2.6. Your height is 20. Half or 0.5. 1 plus 2.6, that's just 3.6. Times 20. Then it's just going to be 36. Units squared. And that's it. You have determined your area. This one here. You have determined your area. Again, I mean, it's normal for people to maybe say, forget the trapezium rule. Okay? So, if you look at this can be divided into two shapes. You're going to see a rectangle, and then you're also going to see a triangle. Okay? There is a rectangle and there is also a triangle there. So in case maybe you forget the area formula of a trapezium, at least try and remember that the area formula for a rectangle is just like L times B, and that of a triangle is just going to be like area is equal to LB, and this case just like half BH, your base and your height, in that way. Okay, so what if someone forgot the trapezium? Let's try to use this format to see how it's going to work. So the area of the bound region will be equal to, notice we are first starting with a rectangle. A rectangle is from here to here, that's just like 1, right? So 1, and then from here to here, that's just like 20. So it's like 1 times 20. Okay, 1 times 20, which I can write in this way, plus, and then remember there is a triangular part here, and of course it's half base times height, right? So half times your base is starting from 1 reaching to somewhere like 2.6. So don't just get 2.6 as your base, it's starting from 1 to 2.6. So you're going to say 2.6 minus 1, which is just going to give you 1.6. So your base is going to be 1.6 times As usual, your height is just going to be 20. Okay, just 20. Let us try to work this out. 1 times 20 is just 20 plus. If we punch, let us try just using our brains. 2 here, 1 into 20, that's just going to be like 10. 1 times 1.6 times 10. 1 times 1.6 times 10, this is just going to be 16. And 20 plus 16, this is still going to be 36. Units squared. So in the case where you forget the trapezium way, if you can still remember the area formula of a rectangle and that of a triangle, it's easy. Just divide it. Rectangle, triangle, find this area, add them. If you still remember this guy, just go directly using a is equal to half a plus b h in that way, and that will be the solutions that you're going to have. Okay, so I really hope this video helps. Thank you very much.